don't realize you could actually paint vinyl siding. Instead of refatting your home, it makes way more sense to paint it. It's less expensive, and you have way more color.
Tremendous selectivity of the Twinplex receiver. So some of you might be familiar with this magazine, Electric Radio. Through the years there have been all kinds of interesting projects in electric radio. One of the favorites, though, that continues to show up year after year is the famous Twinplex receiver. The Twinplex is a receiver that uses one stage as a regenerative and one stage as an audio amplifier for the headphones. This first arrived on the scene in the early 30s, and they were doing it with two separate tubes, two triodes, usually whatever the builder could get his hands on, but some popular tubes were the Type 30 because it had the low filament current requirements and could be run on batteries. But the actual Twinplex itself only came about when dual triodes became available in one envelope. An example is the Type 19 dual triode, and later on the 6SN7 and the 6SL7 came in, and these became the basis for many of these projects in electric radio and lots of hobby magazines all through the 40s, 50s, 60s, and even into the 70s. So this is a Twinplex receiver. Basically it's using a 12AU7 dual triode, and this will be the basis for an experiment that we're going to conduct using a new type of vacuum tube called the Korg Nutube. Now the Korg Nutube is based on electrofluorescent technology, and it is a low emission, low voltage version of a vacuum tube put into this clever package. There's two of them in the package, and we will treat them just like triode tubes. So we have to light up the filaments, and we have to put voltage on their plates or anodes. So we'll start out with the Twinplex receiver, figure out how that's working, and then we will substitute in the Korg Nutube, and this will be a Korg Nutube Twinplex receiver. So you guessed it, of all the things we could try to build with the Korg Nutube 6P1, I thought rather than trying to do some kind of a pedal or fuzz box or some kind of audio, that we would try to do a classic radio. Everybody guessed, oh yeah, Mike's going to do a radio. Yep, it's going to be a radio. And I'm picking on a classic circuit. This is the Twinplex Regen. And the Twinplex really came out of the 30s with the Doral 2-tube. It used two separate tubes and a transformer and so on. This was quickly developed into a dual tube with the Type 19 tube, and the Jones receiver is an offshoot of that. But the Twinplex basically was the two-tube topology that gave you one stage of regenerative and one stage of audio amplification. And this is a modern version of that done by AA8 Victor. And he was using a 6SN7. I'm using a 12AU7 because it gives me a little more flexibility. And this is something I built up some time ago. Hopefully it still works. It uses a 12AU7. It's a pretty straightforward regen with a dual triode, the 12AU7. The nice thing about this is it does use a choke, but there's no transformers. It's all resistance coupled. Some people will, of course, throw stones at this a little bit because it does put the B+ through the headphones. And I know a lot of people hate that when they see the high voltage connected to the headphones. They're afraid that somebody's going to get shocked and their hair will fly, their head will come off, and so on. But I think some of you can figure out if we start to go trying to make this Twinplex receiver work with the Korg Nutube, that we'd have to be using a much lower voltage. So the Nutube can take up to 80 volts. So first a little about this particular Twinplex build. Up here we have the antenna trimmer. That's the same place it would be if this was a Korg Regen. Down below I've got the regenerative control. Tuning in the middle. Up top is the volume control. That's a new control that the Korg Regen does not have. Of course, we have one more stage, the stage of audio, so it needs a gain pot. And then the headphones. So, as you can see on the schematic, the headphones are right in series with the plate, and they use 90 volts DC. I'm running this on 60 volts DC. It's plenty of voltage for a 12AU7 to give you good audio volume and good regeneration. You could probably go much lower. The power supply that I'm using is something that I use for these types of circuits. It's sort of, by changing resistors inside, I can program it for different voltages. This particular one's set up for 25 volts regulated and 60 volts. We can also try the 25 volts on this particular regen. So looking down at the Twinplex, you can see the 12AU7. You can see the 2.5 millihenry choke, a couple of 470 puff caps. It's a pretty standard circuit, and many people have built these things over the years. It's nothing radical. But we do have one issue, and this is the issue that comes up every time that you try to show a simple one-tube or a two-tube radio. How do you hear the sound? Do you expect anybody to be able to hear the sound? If I turn this on and I have the headphones here, right, I can tune in a station. Let's see if I can. Okay, I have a station tuned in and I can hear it. But you can't. If I put it up to the camera, maybe you can. I can tell you it's plenty loud in these headphones. So how do we listen to this in a way that makes sense on the video? It's plenty loud in the headphones, but I want to listen to it so you guys can hear it. So the way I'm going to do this is by using something called an isolation transformer. And this little isolation transformer is about 1 k ohm in and 1 k ohm out. And I'm sending that into our old friend, the LM386 audio amplifier. So most of you will recognize an LM386 amplifier box. This guy's set up to have a gain of 20, which is a lot more than we need. But most importantly, it allows us to drive a speaker. And that's what we're looking for with this. So since we're transformer coupled with this guy here, we don't have a common ground between the receiver and the amplifier. So I like to always add a ground between the two. We can't ground it up front because this is hot. Remember, there's 50 volts both sides of the headphones. And that's another reason why people don't like to put the headphones in series with the plate. They generally like to use some type of decoupling and a capacitor, and so you have a hot and a ground. But that's the way the Twinplex was designed. It's old school from the 30s, so the headphones float. Now, when we turn on the amplifier, it's going to have all kinds of gain. So the first thing I'm going to do is turn the volume control of the Twinplex to about halfway. And then same with the amplifier, I've turned it down as well. Let's turn it on. Tremendous selectivity of the Twinplex. Here's the regen control. The regen control. Okay, let's see how the Twinplex operates on 25 volts DC. Now the volume is noticeably lower. You'd expect that with only 25 volts on the 12AU7.
Fought the massive blaze. Bedford Fire Chief Scott Kruger tells me the yacht was heavily involved upon arrival.
Crews arrived and found it was a very large yacht. The initial thought of a small fire below deck.
Things were made even more difficult by the size of the yacht, which had a 500-gallon fuel tank, making the fire last for hours.
Boy, it sure makes the regen go smoother. There's no doubt about that. Let's go down to a lower frequency. Very nice. Yeah, so the Twinplex is a natural choice for the Korg. We have to understand that the Korg has different impedances, and it's going to act a little bit different. I don't think their marketing was pointed toward this particular application. Really, did we think we were going to use the Korg as an oscillator or as a nonlinear mixer or some other application other than audio amplification? I don't really think so. So we're exploring some new territory here with the Korg Nutube.
_Curly.
Hi everybody, I'm Susan. For years I was a consumer advocate, making sure you were protected. As we get older, it's more important than ever to protect our house and
So this is the unmodified Twinplex running on 25 volts.
He explained I should have a trust 5 years in advance.
The regen is almost totally advanced, and the audio
Listen, I feel really good right now.
is all the way up. You remember before we had about halfway? I have not touched the audio amplifier settings. So we've lost some gain, there's no doubt about it, but the regen certainly is smoother at this lower voltage. So the difference between 60 volts and 25 volts, a little more smoothness in the regeneration control, and a little less volume. So let's take a quick look at this nice data sheet for the Nutube 6P1. Operating temperature and storage temperature seem fine. Filament voltage is pretty tight. They want to be between 0.6 and 0.8 volts on each filament, so we're going to have to be careful there. Grid voltage is rated to plus 5 volts. That's plus 5 volts. So they're not giving us any rating on negative voltage, but we'll see what happens there. The anode voltage, or the plate voltage, is between 5 and 80 volts. That's a pretty tight range. Anode power dissipation, the plate dissipation in other words, is at 1.7 milliwatts. That should raise some hairs on the back of your neck. 1.7 milliwatts plate dissipation? Wow, this thing is really made for low-level processing. The way that we want to use it in this circuit as a oscillator, in effect, as a regen receiver, and an audio amplifier to drive headphones, doesn't seem appropriate. So let's think about 1.7 milliwatts and what it means. So, you know, with a Class A amplifier, you've only got about 25% efficiency. That's if you use a resistor in an H-type bias system. However, if you use a transformer or headphones, you can get up to 50% efficiency with a Class A amplifier. So let's say we magically get, you know, maybe 0.6 or 0.7 milliwatts out. If you consider that, and somehow we had a magic transformer that took us from 100K down to 2K headphones, we might be able to get 1 volt RMS into those headphones. So it's not completely outside the realm of possibility that this thing could drive headphones if it had the proper transformer. Okay, let's assume we have this magic transformer, a 50-to-1 transformer that takes 100K of impedance down to 2,000 ohms. And we need to deliver this 1 volt RMS into our 2000 ohms, giving us this hefty half milliwatt or so of power into the phones. That transformer, basically it's a step down, so we're going to need some DC voltage in order to get an AC swing that's enough to make the 1 volt. So the audio stage, and I'm just talking about the audio stage now. We want to get the maximum power delivered to the headphones from the Nutube operating in Class A single-ended service. We know that the approximate plate impedance of the device, they're saying load it with 300K. I would say the impedance of the device is probably around 100K. So we need a transformer that can step 100K down to 2K. 2K is our headphone impedance. So that's a 50 to 1 transformer. Something in that range, 50 to 1, 60 to 1, 70 to 1, that kind of thing. That's the approximate desired impedance ratio of the transformer that we're looking for. So the next question is, how much swing do we need on the Nutube side to produce 1 volt RMS at the headphones? You may remember that 1 volt RMS into 2000 ohms is around a half a milliwatt, 0.5 milliwatts. That's our target audio power. The impedance ratio is equal to the turns ratio squared in a transformer. It's also equal to the voltage ratio squared. So we'll need the square root of 50 volts on the plate side. That's 7.07 volts RMS, or 10 volts peak to peak of swing on the load line. We could do this with our 25 volts, but the application data and some empirical data point to the fact that the gain is increased in the Nutube as the plate or anode voltage is increased. So I would like to try to use the 60 volt supply. That means we have to consider the biasing chart and limit our static Class A current to around 20 microamps. That's because we don't want to burn up the Nutube by having it overheat. As you can see, this means conventional Class A biasing with negative grid bias. As you look at the chart, you can see that they have a 5 to 80 volt limit on their data sheet. However, their curves here show testing all the way up to the hundreds of volts. So that's really interesting. I wonder if the Nutube can indeed take higher voltage than they have on their data sheet. And that high voltage rating is mostly a safety thing. You don't want inner electrode parts of the tube to arc over and so on. But it looks like they at least tested it at higher voltages. We should not worry about this too much because with the 60 volt VCC, even though we're using an inductive load and the swings are doubled, that double is potential doubling. It doesn't mean we're actually doubling anything. It just means that we have the capability to swing 2 VPP, I guess you'd call it. So I think we're all set to, on the audio side, at least we've convinced ourselves that we have an approach on the audio side. Next part of the data sheet, we're going to go into the RF characteristics because guess what? We have to make this thing oscillate as a regenerative detector. Okay, going a little bit further down on the data sheet, we see the filament current is pretty tightly held. We're going to be using a very advanced device to limit that current. I like to call it the resistor. Our bias voltage, and notice that the test condition is very carefully controlled in this. There's a bunch of caveats and conditions in this particular data sheet. They were running the device at a fairly low voltage. So it's not exactly going to act like we want it to act at our higher voltage. But we can use this as guidance. As you can see, the voltage amplification is very low. And when you see something that low, it indicates a low GM or low transconductance in this device. That's why we want to run a little higher voltage. We want to get a little more gain out of the device. Also, that resonance frequency, That's actually an audio resonance. It's a resonance associated with the filament acting like a guitar string, if you will. So the device is somewhat of a MEMS. If you want, you can use it as a vibration sensor. The anode current is very closely controlled. We're going to be using the chart to make sure we don't over-dissipate the device. Grid current, amplification factor, all these things indicate a fairly low gain tube compared to a 12AX7. A 12AU7 is a medium mu triode. We would consider this device to be a very low mu triode. Finally, the anode or plate resistance of 330K. Once you wrap things on there, that resistance will go down. That's why I think maybe a 50-to-1 transformer is appropriate. We might not get perfect power transformer, but I think that's a reasonable transformer to source. You might not be able to get one that's a higher ratio than that easier. So that high impedance is a frightening thing when you start to talk about RF. As you see with this frequency response chart, the thing naturally rolls off, mostly because it has such a high impedance. The impedance working against any capacitance at all is going to naturally cause an RC low-pass filter effect. And this thing will have a very hard time amplifying above the audio range if you put too much capacitance on the plate of the anode. So you need to limit that. And of course, the cheating way of doing that is to wrap something like an emitter follower or some type of a FET or something like that around the device. I am hoping we don't have to resort to that. That would be just silly to put a solid-state device around a vacuum tube to help it. That kind of defeats the purpose. So we're going to try to make this thing oscillate just as it is. Now, fortunately, in regenerative circuits, you don't need a lot of gain. And we will make up for our loss of gain. How are we going to do that, Mike? We're going to do that by increasing the feedback. That's right. The tickler coil that was, 20 turns with 100 turns on the primary, that's going to have to be increased because we're definitely going to need more feedback to make this low gain device that has a fast roll-off oscillate at anything higher than audio frequencies. We'd like to have this thing oscillating up to 2 megahertz. So let's see if we can do that in the next video. So let's introduce the Korg Nutube 6P1 twin triode. The first question out of most people's mouths with any new product like this is, will it replace an ordinary 12AX7? And the answer is, while they're very related, both are dual triodes, they certainly are not the same. The Korg is a very low mu dual triode, so its effective gain is lower than the 12AX7 by quite a bit. Also, it has a very high anode or plate resistance. So it's certainly not going to be able to drive the same amount of power that a 12AX7 can. So people are scratching their heads and saying, okay, what kind of voltages can it handle? It can handle up to 80 volts DC on the plate or the anode. So at this point, people are saying, well, what do you actually use it for? And the answer is, you use it for effects, specifically for vacuum tube effects. The warm sound that you get from a vacuum tube injected into an ordinary solid state circuit can now emulate what a vacuum tube circuit would sound like. You also are able to get some fairly interesting clipping and distortion effects when you're using it in different types of pedals and music augmenting devices. So it has use in all types of fuzz pedals and so on. And I think it is a bit of a curiosity to many people. And I think that as more people find out about the technology, that the company that developed it, Korg, will be able to take this technology to the next level, which would be to make actual vacuum tubes out of it, which could be used in a more general way to replace tubes like the 12AX7. So let's look at this. This is just coming right out of the package. Notice there's no ESD protection because really there's no solid state device here. This is a electrofluorescent type device, and as such it can handle fairly high voltages without disturbing some PN junction or diode that might Zener or short across. So that's not to say it's completely static resistant. Any device can be damaged if the voltage is high enough. So you can see there's two sections here. These are directly heated filaments. That means there's no cathodes in the dual triode, and this is a dual triode. It's two indirectly heated triodes, and they did that to save power. The idea on this device is to be able to work with solid-state circuits and not hog a lot of power or require a lot of voltage for it to work. The filaments on this thing are 0.7 volts each, so you would be able to light this thing up very easily with a Penlight AAA battery, and it would last a long time because the filament current is only around 17 milliamps, and you could put that same 17 milliamps through both filaments, and this battery would last probably a year. For the high voltage, I'm going to probably work with a couple of 9 volts in series for 18 volts. Just going to be conservative, run about 18 volts on the triodes. Let's see what we can do with this device. So another fact on the Nutube, you will see a lot of schematics and circuits where they put both of these sections in parallel, effectively putting the two triodes in parallel. The reason that they do that is it lowers the impedance, specifically the anode or the plate impedance, by half. So it makes it act a little bit more like a regular tube, able to drive loads that are a little bit lower impedance. So it's better to put the two in parallel than to just leave the other one open. You can get a little better performance by putting the two together. Also, on this lowly Twinplex Regen, it may look simple with just a simple clipboard masonite front and a wooden chassis, but it's really a sleeper. As you can see, we have a steel chassis that backs up the front panel, and things are grounded to that securely, and that wraps all the way to the bottom, and we have a metal chassis on the bottom with ground points. So don't let it fool you. It's got a very good ground system, and that's one of the secrets to the good performance.
Like many drugs, ivermectin comes in doses for human and animal consumption. But according to the Frontline COVID-19 Critical Care Alliance, for prevention and early treatment, the amount of ivermectin taken is a tiny amount. But as the vaccine industry stands to make billions more from a booster regime for the COVID boogeyman that has a recovery rate on average of 99%, and a media industry that feeds off the pharmaceutical industry with countless hours of advertising, the propaganda against ivermectin has been unrelenting.
Well, a new false cure for COVID in high demand. Ivermectin, a drug most commonly used to deworm large animals like horses, is selling out, with many people turning to a...
So marrying the Twinplex receiver with the Korg Nutube, I'm sure we're going to run into some interesting problems. And in the next video I will somehow find a way to mount the Korg in here. And I could do that two ways. I could either make a tube socket adapter so that I have a 7-pin adapter wired into the Korg. At these frequencies you can probably get away with something like that. Or I can mount the Korg on standoffs and wire directly to the bottom of the carrier board, which I have. But anyway, in the next video we're going to find out if the Korg Nutube can be made to oscillate, or regenerate at least, enough to give gain in a regen detector. And can it be used as an audio amplifier? We know that its impedance is very high, so perhaps it won't like to have an impedance as low as a few hundred ohms or a few thousand ohms even. It may rebel against us because it has such a high plate impedance. So stand by for part 2 of the Korg Nutube.